Hi everyone, in this video we are going to see how to find the equations of the direct common tangents and the transverse common tangent when two circles touch each other externally. Let's suppose we have two circles like this, they touch each other externally and their equations have been given up there. Now how many direct common tangents can we have? Well, in fact there's going to be two of them. And how many transverse common tangents can we have? Well, there can be just one through the point of contact of the two circles. So let me complete the construction. First I'm going to join the centers and extend that line. Next I'm going to draw the direct common tangents and then I'm going to assign the names. Let's suppose the center of the largest circle is at point P, whose coordinates are negative g sub 1 comma negative f sub 1, and the center of the smaller circle is at point Q, whose coordinates are negative g sub 2 comma negative f sub 2. And let's assume that the points of contact for the direct common tangent on the upper side, with the largest circle the point of contact is point A and with the smaller circle it is point B. And let's suppose that the direct common tangents would intersect at point D on the extended PQ line. In the previous video I have explained how to prove that the direct common tangents would intersect at a point which lies on the extended PQ line. So in this video we'll just try to determine the equations of the direct common tangents and the transverse common tangent. Next I am going to draw the two radii there, PA and QB, and also I have drawn the transverse common tangent. There's going to be just one of them and that will be through the common point of contact between the two circles. And let's assume that the common point of contact is the point T, where the two circles touch each other. From the given equation, what would be the radius of the first circle? Well, let's say it is r sub 1, which will be equal to square root of g sub 1 squared plus f sub 1 squared minus c sub 1. And similarly, the radius of the second circle would be r sub 2, that is equal to square root of g sub 2 squared plus f sub 2 squared minus c sub 2. And now let's take a look at these two triangles, triangle APD and triangle BQD. Here you see the angle PAD and the angle QBD, they are right angles because we know radius is perpendicular to the tangent at the point of contact. So angle PAD and angle QBD, they will be 90-degree angles, and also PA and QB, they will be parallel to each other because both of them are perpendicular to a single line there, the direct common tangent AD. So PA is perpendicular to AD and QB is also perpendicular to AD. That means PA and PB, they will be parallel. And then angle APD and angle BQD, they will also be equal because they will be the corresponding angles between two parallel lines. And then of course the angle ADP, that is a common angle between the two triangles. So here we have two triangles whose corresponding angles are actually of the same size. That means these two triangles will be similar triangles, and because they are similar triangles, the ratio of their corresponding sides would be equal, which means PD over QD will be equal to AP over BQ, and that will be equal to AD over BD. And from here I am going to take the first part of the proportion and we can write it like this. Now PD over QD will be equal to AP over BQ. Now what is AP? Well, AP is actually r sub 1 and BQ is actually r sub 2. So we can write it like this, and from here we can say that the ratio of PD to QD would be equal to r sub 1 is to r sub 2. That means the point D divides the PQ line segment externally in the ratio of r sub 1 is to r sub 2. Now let's assume that the coordinates of D are x sub 1 comma y sub 1. So using the section formula we can easily calculate the coordinates of D. The x coordinate will be like this, and if we simplify that it can be written like this. So here I am using the section formula for external division. I have already created separate video on this topic. I have shared the link in the description. Feel free to watch that video. So using the section formula for external division, we can find out the value of x sub 1, which turns out to be r sub 2 times g sub 1 minus r sub 1 times g sub 2 over r sub 1 minus r sub 2. And similarly we can calculate the y coordinate of the point D. So y sub 1 can also be written like r sub 2 times f sub 1 minus r sub 1 times f sub 2 over r sub 1 minus r sub 2. So next we are going to see how to find the equation of the direct common tangents. We can take a general equation of a straight line as y minus y sub 1 is equal to m times x minus x sub 1. Here x sub 1 and y sub 1, they are the coordinates of the point D, which of course lies on the direct common tangents. It actually lies on both the direct common tangents. So D is a point that lies on both of the direct common tangents. So we can take a general form of the equation of a straight line like this, and here the challenge is we have to find out the value of m. In fact we have to find two values of m because there are two direct common tangents, so we have to find two values of m. Now let's simplify this equation a little bit. So the equation can be written like this: mx minus y minus mx sub 1 plus y sub 1 is equal to 0. To find the two values of m, we have to somehow create a quadratic equation, and for that we are going to use a little trick here. We are going to find the distance of the center P from the direct common tangent, and that distance would be equal to r sub 1. And now we are going to use the formula for the distance of a line from a given point, and using the formula we can say that the distance of the point P whose coordinates are negative g sub 1 comma negative f sub 1 from this DCT whose equation has been taken as mx minus y minus mx sub 1 plus y sub 1 equals 0. So the distance of point P from this DCT can be written like this, and that is obviously equal to r sub 1. That's the radius of the larger circle. I have created a separate video on this topic. The formula for the distance of a line from a given point, I have shared the link in the description. Feel free to watch that video. Next, I am going to simplify this a little bit. If we bring the denominator to the right hand side, the equation can be written like this. Now to get rid of the absolute value sign, I took a square on both sides. So the equation can be written like this, and the right hand side simplifies to this, which can be written like this. And then on the left hand side, if we get rid of the absolute value sign, then left hand side will look like this, and of course the right hand side will look like this. And if we expand the left hand side, he is going to look like this, and then the right hand side of course remains as is. And then if we bring everything to the left hand side, our equation is going to look like this, which can be reorganized like this. And if you carefully look at it, you will notice that this is nothing but a quadratic equation in m, where m is the unknown variable. Everything else is actually known, because we know the value of g sub 1, x sub 1, f sub 1, y sub 1 and r sub 1. Of course we know all those values from the given equations of the circles. The only unknown here is m, and we have a quadratic equation, so essentially we are going to get two values of m, and that's exactly what we are going to use to come up with the two equations of the two direct common tangents. So let's use the quadratic formula to find the two values of m, and it can be written like this. And from here let's use the plus sign for the first value of m, and let's call it m sub 1. That will be the slope of one of the DCTs. And let's use the minus sign for the other value of m, and let's call it m sub 2, and that will be used as the slope of the second direct common tangent. So then the equations can be written like this: y minus y sub 1 equals m sub 1 times x minus x sub 1. And the other one can be written like this: y minus y sub 1 is equal to m sub 2 times x minus x sub 1. Just using the two values of m, we can come up with the two equations of the two direct common tangents. I hope things are clear up to this point. Next, we are going to try to find the equation of the transverse common tangent. If you look at the diagram carefully, you will see that point T actually divides the line segment PQ internally in the ratio of r sub 1 is to r sub 2. And let's assume that the coordinates of the point T are x sub 2, y sub 2. So using the section formula for internal division, we can find out the value of x sub 2 like this. And similarly, let's try to find out the value of y sub 2, and that is going to be like this. And if we simplify it, it becomes like this. And as you can see, we know the values of r sub 1, r sub 2, g sub 1, g sub 2, f sub 1, f sub 2. We know all those values from the two given equations of the circles. So we can easily calculate the value of x sub 2 and y sub 2. Also, the transverse common tangent is perpendicular to the PQ line, because PQ line is the common line for the two radii there, and tangent is always perpendicular to the radius. So the transverse common tangent, I have abbreviated that as TCT, transverse common tangent. It is perpendicular to PQ. That means the product of the slope of the transverse common tangent and the slope of the PQ line would be equal to -1. So from there we can say that the slope of the transverse common tangent will be -1 over slope of the PQ line. Now what is the slope of PQ? Well, that can be written like this, using the simple formula for slope of a line, where we know the coordinates of the 2 points on that line. So using the simple formula of slope, we can say that slope of PQ line will be like this. And if we simplify it, it's going to look like this: f sub 1 minus f sub 2 over g sub 1 minus g sub 2. And let's plug in that value here on the left hand side. So that will be -1 over this value, which is f sub 1 minus f sub 2 over g sub 1 minus g sub 2. And then finally this is going to look like g sub 2 minus g sub 1 over f sub 1 minus f sub 2. So now we know the slope of the transverse common tangent, and also we know a point on that transverse common tangent, which is x sub 2, y sub 2. So using the point slope form of the equation of a straight line, we can easily write down the equation of the transverse common tangent. and that can be written like this: y minus y sub 2 is equal to the slope times x minus x sub 2. So that is the equation of the transverse common tangent, and this is actually formula number 1. Also there is another formula, and I'm going to show you how to derive that formula. It's pretty interesting. So let's get started with the second formula. The second formula actually looks like this. Now how to derive this? Now to derive the second formula, let's assume that the equation of the transverse common tangent is y equals mx plus b, where we know the value of m, that is g sub 2 minus g sub 1 over f sub 1 minus f sub 2, that is the slope of the transverse common tangent. So we know the value of the slope. So the only unknown here is the b, the y-intercept, right? So if we plug in the value of m, our equation going to look like this. And if we simplify that little bit, our equation going to look like this. And if we rewrite, our equation will look like that: g sub 1 minus g sub 2 times x plus f sub 1 minus f sub 2 times y minus b equals 0. And now I'm going to use the formula for the distance of the line from the center of the larger circle. And using that formula, we can say that the distance of the transverse common tangent from the point P will be equal to the radius of the first circle. And that can be written like this. Here again I am using the formula for the distance of a line from a given point. Here the line is actually the equation that we have there in the green color, and the given point is actually negative g sub 1 comma negative f sub 1. That's the center of the first circle. So using the coordinates of the point P on the assumed equation of the transverse common tangent, we can say that the distance will look like this, and that will be equal to r sub 1. And now if you think about the denominator on the left hand side, that is nothing but the distance of PQ. Using the distance formula for PQ line segment, we can find that this is actually the length of PQ. Square root of g sub 1 minus g sub 2 whole square plus f sub 1 minus f sub 2 whole square. That quantity is nothing but the distance between P and Q. That's the PQ distance. And in this case, because the circles touch externally, that PQ distance again becomes the sum of the two radii, r sub 1 plus r sub 2. So in place of the denominator, I am writing PQ because that is the length of the PQ, and our equation will look like this. And then if we bring the denominator to the right hand side, then our equation will look like this. And that can be written as r sub 1 times r sub 1 plus r sub 2. In place of PQ, I am writing r sub 1 plus r sub 2. And now if we get rid of the absolute value sign, then we can say that the left hand side can be written like this, and the right hand side can be written as plus or minus r sub 1 times r sub 1 plus r sub 2. So I simply got rid of the absolute value sign, and I have used the plus or minus sign on the right hand side. And I'm going to use the same method to find a similar equation using r sub 2 and the distance of the transverse common tangent from the center of the second circle. So it can be written like this, that the distance of the transverse common tangent from the center of the second circle, which is the point Q, whose coordinates are negative g sub 2 comma negative f sub 2, and the distance will be equal to the radius of the second circle. So using the formula for the distance of a line from a given point, we can write it like this. And here again, in place of the denominator, we can write PQ because that is the length of the PQ using distance formula. So this equation is going to look like this, and if we rewrite, our equation is going to look like this, and the right hand side can also be written as r sub 2 times r sub 1 plus r sub 2. And if we get rid of the absolute value sign, we can rewrite the equation like this. And I'm going to denote these two equations as equation number 1 and equation number 2. So from these two equations, we have 4 possible values of B, and we have to figure out which one we need to take and which ones should be discarded. So the first equation that we obtained there in an attempt to find the value of B, that equation kind of looked like this. And from here we can say then B can be written as g sub 2 minus g sub 1 times g sub 1 plus f sub 2 minus f sub 1 times f sub 1 plus or minus r sub 1 times r sub 1 plus r sub 2. Let's call it equation number 3. And also the second equation that we obtained, from that equation we can say that the value of B can be written like this: g sub 2 minus g sub 1 times g sub 2 plus f sub 2 minus f sub 1 times f sub 2 plus or minus r sub 2 times r sub 1 plus r sub 2. And let's call this equation as equation number 4. So now you can see that there are 4 different possible values of B, and we have to figure out which one is the correct one. So we are going to try different combinations of the plus and minus sign, and we are going to play with it a little bit and see which one is the correct value of B. First, I am going to take the plus sign from equation number 3 and plus sign from equation number 4. And then we can say the value of B would be like this if we use the plus sign from equation number 3 and equation number 4. And because the right hand side here represents the value of B, so we can equate them like that. because both of them represent the value of b. So the right hand sides of the two values of b can be equated like this, and by equating them we are going to see if we end up in a crazy situation. So let's see what happens. If we remove the parenthesis, the left hand side is going to look like this, and similarly the right hand side will look like this. And here you see the positive r sub 1 times r sub 2, that term will cancel out each other on both sides of the equal sign. And if we bring all other remaining terms to the left hand side, then the equation going to look like this. And if we rearrange a little bit, we can write the equations like this. And if we multiply both sides by a negative 1, then our equation could be written like this. And finally you see the first three terms on the left hand side actually represents g sub 1 minus g sub 2 whole square, and similarly the next three terms on the left hand side, it represents f sub 1 minus f sub 2 whole square. So our equation is going to look like this. And here if you carefully notice that g sub 1 minus g sub 2 whole square plus f sub 1 minus f sub 2 whole square, that actually represent pq squared. So then we can write our equation like this, and in place of pq I am going to use r sub 1 plus r sub 2. So our equation will look like this, and if we expand, our equation is going to look like this, and then two terms will cancel out each other, the positive and the negative r sub 1 squared. So our remaining equation will look like this, and we divide both sides of this equation by a 2, then our equation will look like this. And then if we take r sub 2 as a common factor, then our equation will look like this. And from here what do we get? Well, we get r sub 2 is equal to 0 or r sub 1 plus r sub 2 is equal to 0, and both of them are impossible. Why? Because we are talking about the radius of two real circles. That means the value of r sub 1 or r sub 2 can never be 0. So r sub 2 is equal to 0 is not a possibility, and the sum of the two radii being 0 is also not a possibility. That means this combination of values that I considered for b is actually not a valid combination. So the combination of the plus sign from both the equations there, it is not a valid combination for the value of b. That means we have to discard this combination. Alright, let's try another combination. So now let's take this combination of negative sign from each of the four possibilities, right? Now we are going to use negative sign for equation number 3 and also negative sign for equation number 4, and then see what happens. So b's values can be written like this if we use the negative sign for both the equations, and if we equate the values of b, then we can write an equation like this. If we remove the parenthesis, our equation will look like this, and you see the negative r sub 1 times r sub 2, that term would cancel out each other on both sides of the equal sign. And then if we bring everything to the left hand side, our equation can be written like this. And if we rearrange a little bit, our equation can be written like this. And next I am going to multiply both sides by a negative 1, then our equation can be written like this. And from here we can write the equation like this, and in place of g sub 1 minus g sub 2 whole square plus f sub 1 minus f sub 2 whole square, I am going to write pq squared because that represents pq squared. And then in place of pq squared, again I am going to write r sub 1 plus r sub 2 whole squared. And finally our equation is going to look like this, and there you see the positive r sub 2 squared and the negative r sub 2 squared, they will cancel out each other, and our remaining equation will look like this. If we divide both sides by a 2, then our equation is going to look like this. And from here if we take r sub 1 as a common factor, then our equation looks like this. And from here what do we get? Well, r sub 1 is equal to 0 or r sub 1 plus r sub 2 is equal to 0. And again this is also not possible. Why? Because the radius of two real circles cannot be 0. That means r sub 1 cannot be 0 because r sub 1 is the radius of a real circle. And similarly the sum of the two radii can also never be 0 because r sub 1 and r sub 2, they represent the radii of two real circles, so they can never be 0, their sum can never be 0. So this combination is also not acceptable. That means we have to discard this combination. Okay, let's try another combination. So next we are going to try this combination, minus sign from equation number 3 and plus sign from equation number 4. Then the two values of b can be written like this, and if we equate the two values, we can form an equation like this. And then we are going to remove the parenthesis, our equation will look like this. And then if we bring everything to the left hand side, our equation can be written like this. And if we rearrange a little bit, our equation can be written like this. And next I am going to multiply both sides by a negative 1, then our equation will look like this, and it can be written like this. The first two terms again represent pq squared, So our equation can be written like this, and in place of PQ I have written R sub 1 plus R sub 2. So our equation looks like this, and from here what do we get? 2 times R sub 1 plus R sub 2 whole squared is equal to 0. Then we are going to get R sub 1 plus R sub 2 whole squared is equal to 0, and that is again not possible, because the square of the sum of the radii of two real circles being 0 is impossible, because the value of R sub 1 and R sub 2 cannot be 0. So this combination should also be discarded. Now we are left with one other combination, so let's try that. The fourth possibility is this combination, plus sign for equation number 3 and minus sign for equation number 4. Then the two values of b can be written like this, and if we equate the values we can form an equation like this, and then if we get rid of the parentheses our equation is going to look like this, and then if we bring everything to the left hand side our equation is going to look like this, and then if we simplify and rearrange our equation is going to look like this, and then I am going to multiply both sides by a negative 1, so our equation would look like this, and now our equation can be written like this. Here again the first two terms on the left hand side, they would represent PQ squared, so our equation can be written like this, and then I am going to replace PQ with R sub 1 plus R sub 2, so our equation can be written like this. And now if you carefully look at it, this actually makes sense. R sub 1 plus R sub 2 whole squared minus R sub 1 plus R sub 2 whole squared is equal to 0. That seems to be perfectly valid. So this is the only acceptable combination for the plus sign and minus sign for the values of b. So case 4, the fourth case, is actually the only acceptable combination. Alright, now let's proceed with this combination. And if we proceed with this combination, here's the values of b, and now I'm going to add them. So we can say 2 times b is equal to the sum of those two quantities which are on the right hand side, and if we remove the parentheses we are going to get the quantity like this on the right hand side, and if you carefully notice a few terms will cancel out each other. The positive and the negative combinations will cancel out each other, and we are going to be left with something like this. And from here we can say then negative 2 times b, if we multiply both sides by a negative 1, right? So negative 2 times b can be written as g sub 1 squared plus f sub 1 squared minus r sub 1 squared minus g sub 2 squared minus f sub 2 squared plus r sub 2 squared. And we can rearrange it like this. And then in place of g sub 1 squared plus f sub 1 squared, we can write r sub 1 squared plus c sub 1. Now why is that? Well, let's take a look. We know that r sub 1 is equal to square root of g sub 1 squared plus f sub 1 squared minus c sub 1. And if we square both sides, we are going to get something like this. By squaring both sides, we get r sub 1 squared is equal to g sub 1 squared plus f sub 1 squared minus c sub 1. And from here, if we rearrange a little bit, we get g sub 1 squared plus f sub 1 squared is equal to r sub 1 squared plus c sub 1. And that's exactly what I have done in the original equation there. So let me get rid of this note. And now if we remove the parenthesis, we are going to get it like this. And there again, you see the positive r sub 1 squared and the negative r sub 1 squared, they will cancel out each other. And also the positive r sub 2 squared and the negative r sub 2 squared, they will also cancel out each other. So we are going to be left with c sub 1 minus c sub 2. So finally we see that the value of negative 2 times b is equal to c sub 1 minus c sub 2. So then let's go back to our original equation of the transverse common tangent. We had the equation like this, and if we multiply both sides by a 2, then our equation is going to look like this. And then I am going to use c sub 1 minus c sub 2 in place of negative 2b. So our equation would look like this. And let's remove the parenthesis, then our equation would look like this. And next I am going to add positive x squared and negative x squared and also positive y squared and negative y squared. Then our equation can be written like this, because what I have added there is essentially 0, but I am doing this to come up with a nice formula here. So if we rearrange a little bit, we can write the equation like this. And here you see the first term is actually the left hand side of the equation of the first circle, and let's call that s sub 1. And also the second part of the equation there, that is actually the left hand side of the equation of the second circle, and let's denote that as s sub 2. When we represent the left hand side of the equation of the first circle as s sub 1 and we represent the left hand side of the equation of the second circle as s sub 2, then the equation of the transverse common tangent would look like s sub 1 minus s sub 2 equals 0. And that's exactly what we tried to derive so far. And this is the easiest equation for the transverse common tangent for two circles that are touching each other externally. I hope the entire derivation made sense. Next, we are going to take an example. Let's suppose we have an example like this. Find the equations of the direct common tangents and the transverse common tangent for these two circles. The equations of the circles have been provided here. X squared plus y squared minus 4x minus 4y plus 4 equals 0, and x squared plus y squared minus 12x minus 10y plus 52 is equal to 0. So let's get started with the solution. If we compare the equation of the first circle with the general form, then we can say that 2 times g sub 1 times x is actually equivalent to negative 4x as given in the equation. And from here we can say then g sub 1 can be written as negative 2 and negative g sub 1 can be written as positive 2. And similarly, the value of f sub 1 turns out to be negative 2 and negative f sub 1 turns out to be positive 2. So the coordinates of the center of the first circle seems to be 2, 2. Negative g sub 1, negative f sub 1, that becomes 2, 2. So we have found the coordinates of the center of the first circle. Now what is the radius of the first circle? Well, let's assume that to be r sub 1 and let's calculate it real quick. If we simply plug in the values of g sub 1, f sub 1 and c sub 1, the radius of the first circle turns out to be 2 unit. Similarly, let's try to compare the second equation with the general form of equation of a circle. From there, we get g sub 2 is equal to negative 6 and negative g sub 2 is equal to positive 6. And similarly, we get f sub 2 as negative 5 and negative f sub 2 is equal to positive 5. So the coordinates of the center of the second circle, which is point Q, its coordinates are 6, 5. That's actually the negative g sub 2, negative f sub 2. Also, let's quickly calculate the radius of the second circle. The radius of the second circle turns out to be 3 unit. So we have found the coordinates of the centers, we have found the radii, and now let's try to find the distance between the centers, and that turns out to be 5 unit. Now what is 5? Can we write 5 as 2 plus 3 and we can write it as r sub 1 plus r sub 2. So this condition can arise only when the two circles touch each other externally. So in this example, the equations of the two circles that have been provided, those two circles actually touch each other externally. So we should be able to find 2 direct common tangents and 1 transverse common tangent. So first let's try to find the equations of the direct common tangents. Let's assume that the direct common tangents intersect each other at point D, whose coordinates are assumed to be x sub 1, y sub 1, and let's quickly calculate x sub 1 and y sub 1. Using the section formula, we can easily calculate this because we know that D divides PQ externally in the ratio of r sub 1 is to r sub 2. So using the same section formula as I described in the theory portion, we are calculating the value of x sub 1 and that turns out to be negative 6. And similarly, the value of y sub 1 turns out to be negative 4. So we have found the coordinates of the point D, and that is negative 6, negative 4. Next, let's take the general form of the equation of the DCT. Y minus y sub 1 equals m times x minus x sub 1. Here the unknown is m. We have to find the two values of m by creating a quadratic equation, and we are going to do that now. If we plug in the values of y sub 1 and x sub 1, our equation going to look like this. And then finally it looks like mx minus y plus 6m minus 4 equals 0. And then we are going to use the formula for the distance of a line from a given point P whose coordinates have been calculated as 2, 2, and that distance will be equal to the radius of the circle, of the first circle of course. I am simply following the same steps as I have described in the theory portion. So using the formula of the distance of a line from a given point, we get a new equation like this. And if we bring the denominator to the right hand side, then our new equation going to look like this. And if we simplify a little bit, our equation looks like this. And then if we take a 2 as common factor out of the left hand side, then our equation would look like this. And if we divide both sides by a 2, then our equation looks like this. And finally, to get rid of the absolute value sign, I am taking a square on both sides. So our equation would look like this. And expanding the left hand side, our equation would look like this. And if we bring everything to the left hand side, our equation looks like this. And finally, the equation looks like this. And here the only unknown is m, and it's a quadratic in m. So the value of m appears to be something like this using the quadratic formula. And if we simplify that, it's going to look like this. And finally, we have the values of m. 12 plus or minus 2 times square root of 6 over 15. Let's take the plus sign for m sub 1, the first value of the slope of the direct common tangents. So m sub 1 is 12 plus 2 times square root of 6 over 15, and let's take m sub 2 as 12 minus 2 times square root of 6 over 15. So those are the slopes of the two direct common tangents. And now I'm going to use those values in the equation of the direct common tangents. I have simply plugged in the value of m in the equation of the direct common tangent, and if we simplify that a little bit, it's going to look like this, and finally it looks like this, and that is the equation of the first direct common tangent. Similarly, let's derive the equation of the second direct common tangent. I have plugged in the value in the equation. The second value, of course, the value of m sub 2. So the equation of the second direct common tangent looks like this. And if we simplify it a little bit, it will look like this. And then if we simplify a little more, the equation is going to look like this. And that is the equation of the second direct common tangent. So we have been able to find the equations of the two direct common tangents. Next, let's try to find out the equation of the transverse common tangent. There is just one of them. And we are going to use the easiest equation, s sub 1 minus s sub 2 equals 0, where s sub 1 is the left hand side expression of the equation of the first circle and s sub 2 is the left hand side expression of the equation of the second circle. Now using this form, our equation will look like this. That is s sub 1 minus s sub 2 equals 0. I have used the value of s sub 1 and s sub 2, and this is the equation for our transverse common tangent. We are going to simplify this a little bit. If we remove the parenthesis, the equation looks like this. And if you carefully notice, the x squared and the y squared terms will cancel out each other, the positive and the negative combinations there. So we are going to be left with something like this. 8x plus 6y minus 48 equals 0. If we divide both sides by 2, then the equation becomes 4x plus 3y minus 24 equals 0. And that is the equation of the transverse common tangent. So we have been able to find the equations of the direct common tangents and the equation of the transverse common tangent. I hope everything made sense. Thank you for watching. See you in the next video.